Hello my dear students, welcome to another physics class. Today we are going to start Kinematics chapter. Before I go to the numerical, let me tell you briefly about the kinematics. Kinematics mainly belongs to classical mechanics. Here we mainly consider the motion of an object. Motion of an object means here you see that suppose a person is here. Okay, this person is here and this person is moving from one point to another point. Suppose following a straight line. Following a straight line. Now here we will consider the motion of this object or the motion of this person without the application of any force. Okay, you must remember that in kinematics we do not consider any force on the object. Okay, so here we consider the motion of this person from one place to another place, one point to another point. Okay, this is the geometry of the motion. Here we consider. Here we consider the geometry of the motion. Geometry of motion here we consider. Okay. Now in kinematics, first we have to think that which terms here we need to describe the motion of this object. Okay. So the terms here we use, that is first is distance. We all know, we are all familiar with these terms. Second is displacement. Displacement. Third is speed. Fourth is velocity. And the fifth is acceleration. Acceleration, right? Now, first we will be discussing about the distance and displacement briefly. Briefly, I will tell you what is distance and displacement. First of all, suppose you are in your school today and this is your home. S for school, H for home. Okay. Now, you are just going back to your home, but today you have very less time. Okay, because you have your tuition. So that's why you just followed the shortest path to reach your home. Okay, you have followed the shortest path. Okay, then this is called your displacement. Then this is called your displacement. Why? Because here you see that you have followed, remember here these are the keywords, you have followed the shortest distance. Shortest distance with direction. With direction. Clear? Here you have followed shortest distance with direction. That's why this is called your displacement. But in the second day, on the second day you have some time. That's why what you have done, you went to your uncle's house. Okay. Then you had gone to your suppose auntie's house, another auntie's house, and then you reach to your home. Okay, so you just followed another path. You followed another path to reach your home because you have some time. So in day 2, you followed another path which have not a particular direction, but you followed another path. Okay, this is called distance. Now you already know that the quantity which has no direction, only it has the magnitude, that is called your scalar quantity, right? Right? And here since displacement has particular direction with magnitude, that's why it is a vector quantity. Very easy. Okay. So that means if distance we consider as your S, then displacement would be S with a vector symbol. Okay. So this is about distance and displacement. Now we will go to the numerical. First numerical. Here is your first numerical. A man has to go 50 meter due north. So suppose a person is here. A person is here. It is going to north. 50 meter. That means this distance is 50 meter. 40 meter due east. That means from here it is going to the east direction with 40 meter, and 20 meter due south. That means is going again to the downward direction with 20 meter. Okay. What distance he has to walk to reach the field? Suppose now if I give the name, suppose this is the point A, and here this is the point B, and this is the point C. Okay. Now therefore you have to find out the distance. Distance means what is the distance traversed by the person, that you have to find out. So therefore here you see that first 50 meter distance, then 40 meter, then 20 meter. So this is the total distance this person traveled. So this is the total distance. So is equal to, here you are going at as 5 plus 4 plus 2, 9 plus 2, 110 meter. This is the total distance. Okay, this is the first answer. Very easy. The second one is what is his displacement from his house to the field. Okay, this is whenever you are asked to find out the displacement, you always remember that you have to find out the shortest distance. Okay, shortest and direct distance from the initial position to the final position. This is the key word. Okay, so here you have to find out the shortest distance, means here you see if this is your initial position and this is your final position, so obviously you have to draw a straight line between them, always. So here this is your straight line and this is your displacement. Okay, this AC, the value of AC, here you have to find out what is his displacement. That means AC you have to find out. AC is equal to what? So how to find out? Obviously here you see that we are getting a triangle. Now suppose this point I am considering as O. Now if this is your 20 meter, then I am giving with another color. This is your suppose 20 meter. If this is 20, then this will also be 20. Therefore this distance will be 50 minus 20, which is 30, right? So and here OC is equal to, since this is 40, so therefore this will be also 40. So you just write down the values. OC is equal to, here you are getting as 40, and the value of OA you are getting it as your only 30, right? Now you do the calculation by applying the Pythagoras law. So from the triangle OAC, okay, you are getting as, if you apply the Pythagoras law, then OC square is equal to, it would be AC actually. AC square is equal to, you are getting as OC square plus your OA square. Now here you see that you know all the values, right? You just put the values of them, like OC square is equal to 40 square plus, here you have 30 square, right? So now you do the calculation. Here you are getting what? 1600 and 900. So therefore 2500, that is your AC square. So therefore AC is equal to, you are getting as 50. Okay. So this is the magnitude of your AC. This is the magnitude. But as I always told in my previous classes also, that whenever you are asked to find out any value of any vector, you have to find out your magnitude as well as your direction. So here I have calculated magnitude. Now what's about the direction? Here you see that direction means you have to find out the angle which is making with x-axis, making with your x-axis. So this is your theta. So tan theta you have to calculate. So how to find out? Tan theta means, here you see that tan theta means, if you give another name here, suppose P. Okay. So tan theta is equals to CP, perpendicular CP over AP. Okay. So you calculate here tan theta. Tan theta is equals to CP over AP. Now what is the value of CP? CP here you see that if this is your 30, then obviously this would be again 30 and AP is 40. From the figure you can tell, right? So therefore 30 over 40. So you just put it here. 30 over 40. So is equal to T over 4. Therefore theta is equal to tan inverse 3 by 4. This is the angle. Now see that this vector is making an angle towards this with each direction towards this south, isn't it? South or north? This is to the north direction. So you have to tell that north to east. North to east. Okay. So here you have to tell theta is equal to tan inverse 3 by 4 with north to east. Okay, so this is the answer. Now here is your second numerical. A particle starts from the origin and goes along the x-axis. Okay, that means suppose if it is your origin, it goes along the x-axis. So this is your x-axis. Okay, I am drawing at the middle. This is your origin and here it starts its journey towards your x-axis to the point 20 meter. So suppose this is your 20 meter. This is your origin A. I am considering this point as your O and A, and then returns along the same line. That means first the person starts or the particle starts its journey from O to A with 20 meter distance. Then again this person or this particle returns the same line, returns along the same line. That means it is following the same line and it is coming back to this origin at the point O, and then it returns along the same line to the point minus 20 meter. That means it goes to the negative x-axis. It goes to the negative x-axis with minus 20 meter. That means magnitude is 20 meter, but in negative x-axis. Negative x-axis. And this is your positive x-axis. Positive x-axis. This is the problem. Okay, clear? Now next is find the distance. Distance means what is the total distance. We are not bothered with the direction, but here we will calculate total distance. So see, first the particle starts from O, then it came to A. That means 20 meter plus. Then again it came back to O. That means again 20 meter distance the particle had to travel. That means 20. Then the particle went to this point, suppose P. Another 20 meter. That means plus 20. This is the distance. Distance is equal to here 60 meter, right? 60 meter is the total distance. So this is the first answer. Second is find the displacement. This, in case of displacement, we have to consider the direction, because I already told you that displacement is nothing but a vector quantity, right? So therefore displacement when we calculate, then first this particle traveled plus 20 meter, okay, plus 20 meter, then again it came back minus 20, okay, then again it traveled minus 20 meter, means along the negative direction, so that's why minus 20, okay. So now therefore here we are getting it as minus 20 meter. So by this, here we are getting the magnitude of this displacement, means if you want to calculate or if you want to say the magnitude of this displacement, then that would be 20 meter. But what is the direction? When you want to mention the direction, that would be along negative x-axis or along the negative direction, okay. So 20 meter is magnitude of the displacement, and minus or negative direction or negative x-axis is the direction. Okay, so this is the answer. Now we have the third numerical. Before we go to the third numerical, first let me tell you briefly about the speed, velocity, average speed, average velocity, and instantaneous speed, instantaneous velocity. First, what is speed? We all know the speed is equal to distance over time, right? Distance over time, and obviously it is your scalar quantity, because distance is itself a scalar quantity, so this is your scalar quantity. It doesn't have any direction. This is a scalar quantity, and I am noting it with O. It won't be having any vector symbol, but it would be only V. And here we have velocity. Velocity is equal to displacement over time, right? And this is your vector quantity, because displacement is itself a vector. So this is your vector. This is your basic difference between speed and velocity. Okay. Now the question is, what is average velocity and instantaneous velocity? See, if you know the average velocity and instantaneous velocity, then you can also understand your average speed and average instantaneous speed, because the difference is only about the scalar and vector. So we will start with the average velocity. Okay. Now again I will give you with the same example with which we started. That is, suppose we have means you were coming to your home from your school. That was the example, if you remember. So this is your school and this is your home. Okay. Now since you didn't have enough time, so that's why you followed the shortest distance, that is you followed the displacement, and thus you reached home with less time. So now what you are having, that suppose you started from your school, and at t is equal to suppose 5 seconds, you have displacement, that is your s is equal to suppose 10. Okay, 10 meter. Okay, and here at t is equal to 10 seconds, you have suppose s is equal to 20 meter. This is your value of the displacement. Now, if I ask you what is your average velocity, okay, average velocity. So the formula is nothing but total displacement, over total time, right? Now here you see that in this duration means from 5 to 10 seconds, here the total time is 10 minus 5, okay, and here the total displacement is 20 minus, here you have 10, right? So therefore this thus you have to calculate. I am not calculating the average velocity, but this is the way. This is the way to calculate the average velocity. Therefore, let me write the formula, that is average velocity is equal to delta S over delta T is equal to S2 minus S1 over T2 minus T1. Now suppose you are asked to find out your velocity at t is equal to suppose 7 seconds. Okay, means at a particular instant if you are asked to find out your velocity, then what you will do? See, average velocity already, if I write it here, V average is equal to delta S over delta T. Okay, now V instant is equal to limit delta T tends to 0. That means this value of delta T will be very, very small. Okay, limit delta T tends to 0, delta S over delta T, okay, is equal to, you can write it as ds by dt. Okay, when delta T tends to 0, then this delta becomes d. Okay, so this is the expression of your V instant. Okay, V instant is equal to ds by dt. Now using this formula we will calculate, we will do numerical, but before that you have to be well known with this theory. Okay, now we may go to the numerical. It is 260 km from Patna to Ranchi by air. So that means if I consider this is your Patna and this is your Ranchi, then this is your distance between them. Okay, this is your Ranchi. So this is your total distance 260 km, which was followed by your aeroplane, and 320 km was travelled by the bus. An aeroplane takes 30 minutes to go from Patna to Ranchi. That means TA, for aeroplane, takes 30 minutes. 30 minutes is equal to, I can write it as half hour, isn't it? And here after that to go from Patna to Ranchi, whereas a deluxe bus takes 8 hours. Okay, 8 hours. Okay, find the average speed of the plane. Therefore you have to find out V average. Okay, now you see V average, as we know that total distance over total time. We know this formula. So total distance by the air is 260, right? 260. See here, displacement is equal to here. Displacement is equal to distance for your aeroplane, because aeroplane followed that path, that is the shortest path, that is the displacement. And as I told that displacement is distance. Okay, but distance is not displacement. So for aeroplane, distance is 260 and displacement is also 260. Okay, both are same. So that's why here you see that V average is equal to total distance over total time is equal to 260 over half. Clear? So is equal to, here you are getting as 520 km per hour. Now here you see that also you are asked the number C. Find the average velocity of the plane. So as I told that for the plane distance is 260 kilometer, displacement is also 260 kilometer. Okay, so therefore if I write here V average, this is your velocity, is equal to total, this is equal to total displacement. This is distance and this is your displacement, okay, over total time. Here is equal to total displacement means same distance, that is 260 over half, is equal to 520 km per hour. Clear about the average speed and average velocity for aeroplane. Now let's go for the bus. See, this is the answer for A, this is answer for C. Now we are doing for B. See, find the average speed of the bus. Now you have to find out the speed of the bus. So as per the question, the bus followed this path, right, which was 320 kilometer. So this is distance, this is the displacement because it doesn't have any particular direction. So now V average, here it is for aeroplane, so I am noting with A, and this is for bus. Okay, so bus, here speed would be, the distance is 320, right? So therefore 320 over 8, so therefore 40 km per hour. This is your average speed for the bus. Now the question is last one, find the average velocity of the bus. See, if you want to find the average velocity of the bus, then the bus has to here follow 260 kilometer distance. Okay, the bus has to follow this 260 kilometers distance, which is displacement, because velocity is equal to nothing but the displacement by time. Displacement by time. So that's why V average, which is velocity, is equal to, again I am writing the formula, that is total displacement over total time. Now the displacement between them can be only one, distance can be any one, but displacement can be only one value, and the value already given, which was followed by the aeroplane, which is 260. Am I clear? And the total time by the bus was taken as your 8 hours. Okay, so therefore you write here as 8. Okay, so if you calculate, you will get the answer as 2.5 km per hour. Okay, so this is the answer. So thus you have to calculate average speed, average velocity for a particular object. Okay, now we will go to the next numerical. Now the fourth question, when a person leaves his home for sightseeing by his car, the meter reads this value. When he returns home after 2 hours, the reading is another value. So I consider here as S1 is equal to 12352 kilometer, right? And after coming home, after returning home after 2 hours, that means delta t is equal to 2 hours, and the last after coming home the reading is 12416 km. What is the average speed of the car? So average speed, the formula is nothing but total distance over total time. Right? Now the total distance here is what? Delta S over delta T is equal to S2 minus S1 over T2 minus T1. Okay. So S2 minus S1 if we do, then we are getting it as equal to 1, 2, 3, 1, 2, 4, 1, 6 minus 1, 2, 3, 5, 2, right? Over 2 is equal to, if you subtract them, then you are getting as 4, 6, 2, 32 km per hour. Okay. So this is the answer. We are asked to find out the average speed of the car. This is the answer of A. Next question is, what is the average velocity? Here you see that suppose this was the person's home, okay, and this was the destination, before destination. Now what he did actually, for sightseeing, he went to that distance, his destination, and after that again he came back to home. That means what we know, that average velocity is equal to final position minus initial position, right, by time. But here you see that the final position and initial position are same. That means h minus h over delta t. So ultimately here you are getting the average velocity as 0, because here his initial and final position is same. So that's why here displacement is 0. If displacement is 0, then here the average velocity will also be 0. Okay, thus you have to calculate it. The next numerical is the fifth one. An athlete takes 2 seconds to reach the maximum speed 18 km per hour. That means here the time delta t is equal to 2 seconds. And the maximum speed is, that means I can write it as V2. Okay, V2 is equal to 18 km per hour. So is equal to 18 multiplied with, I am just converting it to meter per second, 1000 over 3600. Okay. So here you calculate it, then you are getting it as 5 meter per second. This is V2. But here I can consider V1 as 0. Okay. When time T1 is 0, then the initial velocity was also, speed was 0. What is the magnitude of the average acceleration? Okay. So A average. Average acceleration, the same formula. Okay. V2 minus V1 over T2 minus T1. That means delta V over delta T. Okay, kind of. So E is equal to, V2 means the value we know, V2 is equal to 5 minus 0. T2 is 2 minus 0. So is equal to 2.5. And the unit will be meter per second square. So this is the way to find out the average acceleration. Okay, average acceleration. So students, in a nutshell, if I say that today we have discussed about the distance, displacement, speed, velocity, average speed, average velocity and average acceleration. Now we know the formula of them. We have also done the numerical based on them, and on the next day we will be discussing on the graph between them. Till then, stay happy, stay healthy and practice the numericals whatever we have discussed. Bye.